Dear students, in this is the third lecture on finite differences. In this lecture, we will discuss about the relationship between the different operators like forward operator, backward operator, central operator, averaging operator, and differential operator. Okay, now we will prove the relations between these operators. Now we have to prove this relation between the operators. Del equal to E minus 1. Forward, this is the forward operator and this is the shift operator. Backward operator, del equal to 1 minus E inverse. Central operator, del equal to e to the power 1 by 2 minus e to the power minus 1 by 2. Mu, which is an averaging operator, this is equal to 1 by 2 e to the power 1 by 2 plus e to the power minus 1 by 2. This del equal to e del e equal to del e to the power 1 by 2. And fifth, e equal to e to the power hd, where d is a differential operator. Okay. Now we prove one by one. Here, this del is a forward operator. This reverse del, this is the backward operator. This del, we know that this is the central differences operator. Forward differences, backward differences, and central differences operator. And this E is a shift operator. Mu is an averaging operator. And this D, capital D, is a differential operator. Is a differential operator. Now we know that we can define this forward operator for a function fx or yx by yx plus h minus yx. We can define this backward operator, del yx is equal to yx minus h. We have all these relations. Okay, this is This is the definition of forward difference operator. This is the definition of backward difference operator. And we know that definition of the central difference operator, y x plus h by 2 minus y x minus h by 2. We know that this shift operator er y x is equal to y x plus r. Okay. And also we know that definition of averaging operator is equal to 1 by 2 y x plus h by 2 plus y x minus. This is the definition of averaging operator. Okay. And D is the differential operator. We know that this D is the differential operator, that is d upon dx. Okay. Or we can write this in this manner, that is d of fx is equal to f dash x. We can write this is the differential operator. Now one by one we will prove all these relation between different operators. Now number 1, del is equal to e minus 1. Okay. We know that del yx, by the definition of forward difference operator, yx plus h minus yx. Okay, that is what we can write it, del yx is equal to, we can write this as eyx minus yx, since we know that er yn is equal to yn plus r. Okay, here n plus r, yn is equal to yn plus r, means here r equal to 1, yx plus h, we can write this as eyx, that is del yx is equal to e minus 1 yx. Okay, that is del is equal to e minus 1 or e is equal to del plus 1. That is, first relation is now proved. Now we come to second relation. Second relation, we have to prove that this backward operator is equal to 1 minus e to the power minus 1. Okay, we know that by the definition of backward differences, del yx is equal to yx minus yx minus h, that is del yx is equal to yx minus, this is E inverse yx, since E minus 1 yx is equal to yx minus h. Okay, and here Ex yx equal to yx plus h, that is del yx is equal to 1 minus E inverse, here yx is the common term, that is del is equal to 1 minus E inverse. Okay, now second relation is now proved. Now we will prove third relation. Third, this is the relation between central operator and shift operator. E to the power 1 by 2 minus E to the power minus 1 by 2. We know that by the definition of shift central operator, del yx is equal to yx plus h by 2 minus yx minus h by 2, that is del yx equal to e to the power 1 by 2 yx minus e to the power minus 1 by 2 yx. Okay, since e to the power 1 by 2 yx is equal to yx plus h by 2 and e to the power minus 1 by 2 yx is equal to yx minus h by 2, that is del yx is equal to yx is the common term, e to the power 1 by 2 minus e to the power minus 1 by 2 yx, and we have del is equal to e to the power 1 by 2 minus e to the power minus 1 by 2. Now this is the relation between central operator and shift operator, which is proved here. Now we will prove next relation, that is fourth. Here fourth relation is, this is the relation between averaging operator and shift operator. Minus 1 by 2 and we know that by the definition of averaging operator, mu yx is equal to 1 by 2 yx plus h by 2 plus y x minus h by 2. That is mu yx is equal to 1 by 2, and we know that yx plus h by 2 is e to the power 1 by 2 yx, and yx minus h by 2 is e to the power minus 1 by 2 yx. By the definition of shift operator, we can write it e to the power 1 by 2 yx plus e to the power minus 1 by 2 yx. That is mu yx is equal to 1 by 2 e to the power 1 by 2 plus e to the power minus 1 by 2 yx. Also we can write it mu is equal to 1 by 2 e to the power 1 by 2 plus e to the power minus 1 by 2. This is the relation between averaging operator and shift operator. Now we will prove the next relation. That is, we have to prove this forward operator equal to e into backward operator. That is, backward operator e is equal to del e to the power 1 by 2. Now, we know that by the definition of what we have, since e del yx, what will be this? E del yx, this is the backward difference operator, and by the definition of backward difference operator, this is yx minus yx minus h. That is, we can write it eyx minus eyx minus h, and by the definition of shift operator, we can write it yx plus h minus yx minus h plus h. That is, we have yx. Okay, means this is what is and this is the definition of del yx. That is, we can say that e del is equal to this forward difference operator del. Okay, now we know that del e yx, that is del yx plus h, that is yx plus h minus, by the definition of backward difference operator, this is yx plus h minus h, means this is equal to yx plus h minus yx, and this is the definition of forward difference operator. This is the definition of del yx, or we can say del e is equal to this del. Okay, these are the definitions which I told you in starting of this lecture. This is the definition of forward difference operator. This is the definition of backward difference operator, definition of central difference operator, definition of shift operator, and definition of averaging operator. Okay. We have to prove one more thing. This is also equal to del E1 by 2 equal to this del. That is also, we know that del E1 by 2 yx is equal to del, by the definition of shift operator, yx plus h by 2. Now we apply definition of central operator. This is the definition of shift operator. Okay, this is a definition. Now we apply definition of this central operator. Yx is equal to yx plus h by 2 minus yx minus h by 2. That is what we can write here. Here we can write it. This is equal to yx plus h by 2 plus h by 2 minus y x plus h by 2 minus h by 2. That is del E1 by 2 yx is equal to yx plus h minus yx. And this is the definition of forward difference operator, del yx, or equivalently we can write it del E1 by 2 yx, that is del yx, or we can write it del E1 by 2 is equal to del. Okay. Now from all these three relation, means relation number 1, relation number 2, relation number 3, and relation number 4, what we can say that this del equal to, that is this del equal to E del equal to del E equal to del e to the power 1 by 2. Okay, this is now proved. Next we have relation between shift operator and differential operator, that is E equal to e to the power hd. Okay, now we know that EFX, by the shift operator, EFX is equal to F x plus h. Here h is the interval of differencing. Okay, this is already we know that h is the interval of differencing. Now we expand this by Taylor's theorem. This is equal to EFX is equal to Fx plus h f dash x plus h square upon factorial to f double dash x plus and so on. That is, this is equal to fx plus, we can write this h d of fx. F dash x means d of fx plus h square upon factorial 2 d square of fx and so on. Here fx is the common term, that is 1 plus hd plus h square d square upon factorial 2. We can put outside this fx, and that is efx, and this is the exponential of, this is the for definition of e to the power sd. This is the exponential series e to the power sd fx, that is e equal to e to the power hd, which is the relation between shift operator and differential operator. Okay, and now these are the images of my today's lecture. You can take screenshot of these images. This is the lecture number 1. Lecture number page number 2, and this is the page number 3. I think this video lecture on this topic, finite differences, relation between the different operators in finite differences, is clear to all of you. If you have any queries regarding this video lecture, then you can comment on comment box, and if you feel this video lecture is helpful for you and you feel it is useful, then please like and subscribe this channel, so that I can be more motivated to prepare new videos. And also you can press bell icon for getting notifications about my videos. Okay, thank you very much. Have a nice day, and Bharat Mata ki Jai.